Hi, this is Mrs. Kalinicki. Alright, let's get started on the review today. Today's homework, we're going to go over it really quickly. Number 96. Based on the picture, P stands for probability. What is the probability of your getting a star? 2 out of 6. The chance of getting a square, 3 out of 6. The chance of getting a circle or a square. Again, we want one instance of that. So there are 4 circles or squares out of 6 total. When I want 2 things to happen, such as the next question, I have to multiply their 2 probabilities. What is the probability that I'm spinning a 2 and then a 2 when I'm spinning the spinner shown at the right twice? So 1 out of 8 to get my 2. To get a 2 the second time, again 1 out of 8. So my chance of both of those things happening is a 1 out of 64. The next question, based on our class with the 10 students in it, if I select a student and then select another without replacement, what is my probability of picking Jake and then Lena? Okay, Jake is only 1 out of the 10 students that I have. After I pick him, I can't pick him again. Now I only have 1 out of 9. 1 represents the Lena out of 9 students left to pick, which makes a probability of 1 out of 90. Boys, I have 6 boys in my class, and if you didn't know, you could count them. 6 out of 10 for a boy, but then I only have 4 girls left out of the 10, but only out of now 9 if I pick a boy first. That final probability is 24 out of 90. Calculator OK, predict. If a survey says 2 out of 5 students like pizza, how many out of 900 should like pizza? So I take that 2/5 and I multiply it by 900 to get 360 people should like pizza. And finally, based on the chart below, how many boys would be expected to be in a class of 30? So 3 boys out of 8 total. You see how I added 3 plus 5 to get 8. So 3 out of 8 are boys times the 30 kids in my class. My answer was 11.25, so I'm going to round that to about 11 people. We don't want to round people. We don't want to say 11 and a half people. We want to say 11 people. Okay, so the next thing you're working on is 15 minutes of independent work on your review packet. This is a review packet. It's very similar to the test that you're going to get tomorrow, so take it seriously and work on it. And when you're ready, come back and play the video and I'll go over the answers with you. Okay, welcome back. So, a box contains 4 blue, 1 purple, 2 green, and 5 white pencils. And again, just like class, I drew these on my paper to help me. A pencil is drawn and not replaced. That's important. That means it is a dependent event. That means my second pick is going to depend on what I picked the first time. Okay, so it says determine the probability that I pick a blue one and then a green one. So my chance of picking a blue one right now are 4 out of 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 out of 12. And again, I'm going to take my finger and kind of cover up one of the blues, and now I'm looking how many greens are there because I want to pick green next. Okay, so there's 2 greens out of, now there's not 12 because I kind of used one of the blues. Now there's only 11. So I multiply those, and oh no, my answer's not there. What do I do? Oh, I'm going to try to reduce. If I can reduce, my answer will be on the sheet. So I'm going to do 8, ABC 132, and up. Hey, one of those works. Which one? Choice C. So that reduces to 2 out of 33. Okay, redo the question. Now I didn't cross out anything. Now I want to know the probability of getting a white one and then another white one. Chance of getting my first white one is 5 out of 12. Because it's not being replaced, I'm going to cover one of the whites up. My second time when I pick to get a white is only 4 out of 11. Again, I'm going to multiply across 20 out of 132. Again, oh no, my answer's not there. What do? I put it in my calculator first. I got 5 over 33. I still don't see that answer. So I know it's probably not going to be these 2 fractions right here. So it has to be one of these percents. How do I change this fraction to a percent? I take 5 and divide by 33, and I get this decimal, 0.1515 What percent is that? Well, it's pretty obvious. It's going to be choice B. Because I moved my decimal point over 2 spots, and that's where that decimal is. So your answer is choice B. Moving on. Number 3. A jar contains 4 red, 9 green, ooh, you didn't see it, and 1 blue. There it is. Predict how many times out of 224 that I will not choose a green marble. Okay, so that means I need to write a fraction that represents me not choosing a green marble. So 1, 2, 3, 4, 5, 6, 7, 8. There are 9 greens. 4 reds, 1 blue. So the chance of getting a green is 9. The chance of not getting a green is 4 plus 1, which makes 5. So there's 5 not green ones out of 15. And I want to take that fraction and I want to times it by the number that I'm trying to predict out of. And what will I get? 5 ABC 15 times 224. Sorry, technical difficulties with my calculator. Uh-oh, I didn't get one of these answers. Did I do something wrong? Maybe. Oh, that's why. There's only 14, not 15. I made a mistake. Did you figure out my mistake? Yeah? Alright. Sorry. There's only 14. So 5 out of 14 times 224. There you go. That'll get me 80. Alright, did it. Next one. Mark spins an arrow on a spinner with 8 equal sections, and they are labeled E, F, G, H, J, K, L, M. Then picks a numbered ball 1 through 15. What is the probability the arrow will stop on the letter G and the numbered ball will show an even number? All right, I gotta reread that with the first part. What is the probability the arrow will stop on a G? That probability is 1, because there's 1 G, out of, I don't even need to count them, 8. The second thing I need to figure out is how many times the numbers are going to land on an even number. So there's 1 through 15, so I'm going to count. There's 2, 4, 6, 8, 10, 12, and 14, because I'm not going to higher than that. So there are 1, 2, 3, 4, 5, 6, 7 numbers out of, well, there's 15 numbers. All right, let's see. 1, 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that's 15. Multiply those straight across, and hopefully, I'm going to guess I'm going to get 120, and I do. So my answer is 7 out of 120. Next page. Again, if you didn't get to this part yet, or not everyone's up to this part yet, just pause the video and come back to it when you are. All right, next one. Tables below shows the number of each type of donut it makes every day. Chocolate donuts, coconut donuts, cream fudge donuts. Mary's Bakery. If a donut is selected at random, what is the probability of choosing a cream fudge donut? So I see the number 9 here. Okay, that's part of my probability. 9 out of, I'm going to need to add up all these guys to figure out what my total was. And my total is 45. Now, since I don't see that choice here, I'm going to try to simplify using my calculator. 9 ABC 45, and I get 1/5, which is a choice. So there we go. Again, on your multiple choice, really important for you to show work. If you do not show this kind of work, I'm not going to give you full credit, even if you get the answer correct. So make sure you're showing work. It will improve your chance of getting them right. Number 6. Here's my spinner. What is the chance? What is P 4 then 4? When spinning the spinner shown at the right twice. Okay, so I want the probability, that's what that P stands for, of getting a 4 and then getting another 4. My first chance of getting a 4 is 1 out of 6. My second chance of getting a 4, well, because these are independent events, doesn't matter what I get the first time, I can get every number again on the second try. I will also have a 1 out of 6 on my second try of getting a 4. And that probability multiplied across will get you choice A. Okay, next one. What would be the total outcomes in choosing fried or scrambled eggs with bacon, ham, or sausage with American mozzarella or Swiss cheese? Okay, that sounds like a counting principle question. Or you could have drawn a tree diagram. I have to pick choices. Here are my choices. I have to decide fried or scrambled eggs. That's 2 choices. Ham, bacon, or sausage. That's 3 choices. American mozzarella or Swiss. That's another 3 choices. What do I do with my choices? I multiply them. 3 times 3 is 9. 9 times 2 is 18. So my answer is choice C. Okay, next one. Gina rolls a prime number 18 out of 40 times. 18 out of 40 times. What is the experimental probability of not rolling a prime number? Okay, so if this is rolling a prime number, what's not rolling a prime number? Well, that means there were 18 prime numbers out of 40. So what's left over? Well, if I take the 40 and I subtract the 18, I'll figure out how many numbers are not prime. And that is 22. Well, the chance of getting it is 22 out of the same 40. Again, I don't see my answer. Don't freak out. Just put it in your calculator. And, it did simplify to choice D. Next one. Jack's closet contains 2 hats, 1 jacket, and 5 sweaters. Again, even though they're not colors, I can still write the letters out to help me. Jack selects 1 item at random and does not return it. That's important. That's important when you need to know about your probability, about your second fraction. That means I'm covering up my page, I'm covering up my item when I'm done picking it. What is the probability that he selects a hat and then selects a sweater? So let's start with the hat. Chance of getting a hat, 2 out of 8. Once I choose the hat, I no longer have it. I'm going to cross this one out because I don't have any more problems to do with this situation. Now I want to choose a sweater. Well, there are still 5 sweaters left, but now only out of 7 items. Multiply across, I get 10 out of 56. I don't see it. So, calculator, which will reduce it to 5 out of 28. Choice B, sorry, I know, like the number 13. Okay, again, this number 10 is very similar to number 18. If the probability of choosing an even number, that should say 8 out of 17. What's the probability of not choosing an even number? Okay, well, an 8 out of 17 means there are 8 even numbers out of 17 total. Okay, so if there are 8 even numbers, I'm just going to subtract those away from the total and figure out that there must be 9 not even numbers. So probability that I would pick a not even number would be 9 out of 17. Number 11. The table below shows the test scores of 75 students. What is the experimental probability that the next student's grade will be 75 or less? All right, which one of these kids got 75 or less? Well, these guys got 75 or less, these guys got 75 or less, and these guys got 75 or less. So I have to total those guys up. That's 30 kids altogether when I add it. 30 out of, well, if I have to add the 30 onto the 45, I'm going to get 75. So my grand total is 75, but these 3 groups were the 30. So 30 out of 75, which is there. All right, choice B. Next one. Tom can order a deep dish pizza or thin crust pizza with 3 different toppings. The topping choices are mushroom, sausage, and onions. In the space below, draw a tree diagram for all the possible combinations using 1 type of crust and 1 topping. Okay, so I'm going to start with, which I could start with either one I want. I'm going to start with the deep dish, the type of crust I'm picking. So I have 2 choices, deep dish or thin crust. And I'm going to just separate this with a line to show you that this is the tree diagram area. This is just my little workspace over here. Okay. So I have 2 choices. I'm going to choose crust first. Then, after I choose a deep dish crust, I'm going to have to pick a topping. And I have 3 choices. I have mushroom, I have sausage, and I have onions. And again, same thing for the other one. I have mushroom, I have sausage, and I have onions. And I'm going to just draw the lines to connect to show the combinations. Now, a way to check my work to make sure I drew it correctly is to do the counting principle. The counting principle says I take the number of choices that I have, the number of options. So I have 2 options here, and I obviously have 3 different toppings, and I multiply them together to get 6. And I should, in my last